Hello everyone, welcome back to mychemcorner. So in today's video we're going to do a revision on name reactions from the chapter Alcohols, Phenols and Ether. So let's focus on this particular chapter to learn what all name reactions are there. There are not many, very few of it. So the first one that we have here is esterification. Alright, so under esterification reaction, as the name suggests, we're trying to prepare an ester. So here our starting material is going to be alcohol plus you can use for this, and I'll just separate this in such a way it's easy for you all to understand. I'm just writing the carboxylic group the other way so that to show the elimination of reactants becomes easier. Now if you know, when you have learnt even in Viva question for the PUC students, you know that when you learn esterification reaction, this takes place in the presence of an acid. So here you need to write a H plus also. So here when the reaction is trying to break, you have the bond breaking over here. So from alcohol, H plus comes out and OH from carboxylic acid. So what is happening here? You are forming a byproduct as water. Then the remaining will form bonds. So I'm just putting the other way, RC double bond from here, RC double bond O. This is going to bond with OR from alcohol. So here you're trying to produce ester from a carboxylic acid. Alright, you're trying to produce it from carboxylic acid. Say for example, I'm taking an example from here where R is taken as CH3 and I'm trying to take here and R dash, you can either take it as CH3 or you can take it a bigger chain also, but you have to be comfortable in answering. Now same process here also. Eliminate water molecule by breaking bond of alcohol of OH and here between carbon and oxygen. Now when you do that, you form byproduct as water. From the carboxylic acid you have CH3, C double bond O, and from alcohol you have OCH3. Okay, now this is going to be methyl acetate. Alright, so that is your product formed when your reactants for this particular esterification reaction is one alcohol plus a carboxylic acid. Alright, so the reaction is not going to be restricted here. You can use others also. So let's move to the second one. Under esterification, the second type is, I'm still taking an alcohol only. I'm just trying to change my other reactant. So instead of taking an alcohol, I am just taking an anhydride. In the same way, I'm going to put an acid over here. So this here is an anhydride. Alright, now when you try to break a bond, it remains the same. From alcohol, the oxygen-hydrogen bond will break and this is going to form bonds with here. Alright, so here the bond will break. Hydrogen being positive will bond to the negative center of oxygen here and your byproduct here is going to be R, C double bond O and OH. Alright, now the remaining part, let's see. R dash, C double bond O. This is coming from the anhydride. The remaining comes from the alcohol. O, R. So here you have ester and you have a carboxylic acid as the byproduct. Alright, so if you take an example where both R groups are given, then you can take CH3, CH3. So let's take an example. I have CH3OH plus R groups. I'm just taking CH3 just to make my reaction clear and you ensure that the reactions are correct. You don't have to go for any fancy bigger ones. You just have to ensure that your answers are correct. So I've taken methanol and I've taken acetic anhydride. So here the same thing. Between oxygen and hydrogen the bond breaks. Here between the carbon and oxygen the bond will break and it will form a reactant. So let's write the byproduct. I have CH3, C double bond O and O with a hydrogen from the alcohol. Remaining part let's write CH3, C double bond O and OCH3 coming from alcohol. Alright, again methyl acetate and acetic acid. So this is the second type of reaction where I have alcohol plus anhydride, which will give ester plus carboxylic acid. Alright, the previous one, if you see, it is alcohol plus carboxylic acid giving ester plus water. The difference is in the byproduct. Alright, now the third type, let's see. We have ROH. We're just slightly trying to change our compound here. We will do RCOCl. We are trying to take acyl chloride. Okay. Now here in the presence of H plus. Now in this case also, let me just put the molecule in the other way where, forming the bond becomes easy for us. So just put Cl here. C double bond O and R group. Now when I'm trying to form bond, oxygen-hydrogen bond will break. You will get this bond broken here. So in this case, what is my byproduct? My byproduct is going to be HCl. The remaining, let's just bond R, C double bond O from the acyl chloride and OR from the alcohol. So this is going to give me ester plus HCl. If I take an example, this is going to be CH3OH plus Cl, C double bond O, CH3 with a H plus. Here also it's going to remain the same. The oxygen-hydrogen bond will break. It picks up the Cl, which is a negative center. And when I get the byproduct, it's HCl. And here this is going to be CH3, C double bond O coming from the acyl chloride and OCH3. So here what is it? It is going to be alcohol plus acyl chloride giving ester plus HCl. So if you see, they're all derivatives of carboxylic acid. Because they are derivatives of carboxylic acid, main product will remain ester. Byproducts will change to HCl in terms of acyl chloride, carboxylic acid in terms of anhydride, and water in terms of carboxylic acid. Alright? Alright. So there is one reaction with respect to a aromatic system. So let's see how to do it. So that is a preparation of a medicine. So I'll just put it down here side by side. I'll also explain it to you how to do it. Alright. So here I'm going to take is a aromatic system which has COOH here, and in the ortho position there is an OH. So this compound is called as salicylic acid. This with acetic anhydride, in the presence of acid. Very simple. This is the same logic. Because you have acetic anhydride, it is not the carboxylic acid that's going to react, it is the alcohol that's going to react. So I have OH from here, alright, and I'm going to have a breakage here. Okay, so let's write the part of the molecule. As byproduct, we have CH3, C double bond O, O, and the hydrogen coming from the aromatic system. Now the remaining part of the aromatic system, let's write down. The COH remains untouched. So I'm just going to write COH, oxygen, C double bond O, and CH3 coming from the acetic anhydride. Now this one is, to the salicylic acid, I've just brought an acetyl group, right? It was, if I change this entire group over here to hydrogen, then it would become salicylic acid. But instead what happened? Instead of that hydrogen, one acetyl group came in. Therefore, I'm going to name this group as acetyl salicylic acid. Now this is a very common name when you go to a normal medical store. So this is called as aspirin. Alright, so this is also a preparation of aspirin. Alright, so that is basically what an application of your esterification reaction is. Now let's move to the next name reaction, which is coal-base reaction, a very simple one. Alright, now the coal-base reaction, we will take phenol as our starting material. So we have phenol. Okay, now to phenol I am going to add NaOH. When I add NaOH, in this case, it is going to abstract the proton. So that means this NaOH added is an alcoholic NaOH. Alright, when it abstracts a proton, what will you get? O and A, because OH minus picks up the proton, goes out as water molecule. So this becomes sodium phenate. Now, this will be treated with carbon monoxide in an acidic medium to form OH and COOH. How am I getting this? Alright, I get COOH, this hydrogen coming from the acidic medium. Where is this hydrogen coming from, which is on the alcohol? Initially, at this position where COOH is, you had a hydrogen because it's on the benzene ring. Right? Each carbon atom in a benzene ring is having hydrogen. So that hydrogen goes to your alcoholic group here. Alright. So here you're forming 2-hydroxy benzoic acid. For this name reaction, name of the compound, you'll have to just go through the IUPAC naming. And the common name of this is going to be salicylic acid. Alright, so that's pretty much about coal-base reaction. Alright, now next one is going to be Riemann-Tiemann reaction. Very commonly asked reaction in exam. Riemann-Tiemann reaction. Alright, so here in Riemann-Tiemann reaction, you're going to take same reactant again, a phenol. Okay, now for this, phenol will be treated with CHCl3 and aqueous NaOH. Now aqueous NaOH, what happens here is it's going to replace the hydrogen and give O and A, and CHCl3 will go to the ortho position. Alright, so this will become ONA, and this will become, instead of CHCl3, it will become CHCl2. Why? Because one chlorine atom will pick up the hydrogen which was initially at this place and move out as HCl. Now this particular molecule here is going to be an intermediate. You can easily extract them and study their property. The last step is going to be reaction with NaOH to form ONA, and this compound here will undergo reaction to give CHO. In the last one, ONA needs to be converted to OH. So we just add a H plus and it will get converted to OH and CHO. Like this in the ortho positions, when these groups are present, this is going to be called as salicylaldehyde. So Riemann-Tiemann reaction is the preparation of salicylaldehyde from phenol. Coal-base reaction is the preparation of salicylic acid from phenol. And now the last reaction will be Williamson's ether synthesis. This is coming from ether. So Williamson's ether synthesis. Now in this I'll just put a general reaction. RONA plus R-X. Now what is RONA? It is nothing but sodium alkoxide reacting with an alkyl halide to form. So this Na will react with X to form Rx plus ether will be formed. So as the name says, it is the preparation of ether. Now very important thing is in Williamson's ether synthesis, it's very important to know the nature of alkoxide and alkyl halide utilized. So you can aramse use primary, secondary and tertiary alkoxide, but you can only use primary and secondary alkyl halide. I'll tell you a reason why to it. Say for example, I'm taking the alkoxide as CH3ONA, which is a primary alkoxide. And I'm going to take a alkyl halide which is of a tertiary nature. I am not supposed to do it, but I am taking it to show you why I am not supposed to do it. So I've taken a tertiary alkyl halide. So this is tertiary, this is primary. Now when I do a reaction, what happens is, when this Cl bond breaks, what is the nature of carbocation in this alkyl halide? They are tertiary carbocations, and we all know that tertiary carbocations are highly stable. Alright, and because of that, your alkoxide will no longer act as a nucleophile and form ether as per the reaction here. Instead, this will start acting as a base. Okay, alkoxides are very good, very strong bases. In the presence of a tertiary alkyl halide, instead of acting as a nucleophile, it's going to act as a base. And when it acts as a base, it will abstract a proton from one of the beta carbons. Now then it will follow Zaitsev rule. Alright, it will follow Zaitsev rule, doing the beta elimination reaction, and you will end up forming an alkene here. Alright, so from the beta carbon, you will lose one hydrogen. The Cl also goes out and you will form a beta carbon. Alright, so here I am going to get a CH3OH plus NaBr. So this is the reason why people tell you are not supposed to take a tertiary alkyl halide, especially in case of Williamson's ether synthesis, because due to the stability of a tertiary carbocation, the functionality of the alkoxide will change from nucleophilic to functioning as a base. Therefore, it will not give ether as the product formation. So this is one special case to be taken care of when you give examples. Please give only both, specifically give with respect to primary. I think there your problem is solved. When you move to tertiary alkyl halide, you will not get the desired product. Alright, so these are your basic, your 4 name reactions that you have. Please go through this so that you know that which of the name reactions that are the ones that you need to focus more on. Alright, so I'll see you in the next video. Thank you so much.